not nameless.
So, looking at number 3. Looking at number 3. This looks like a derivative. It looks like we're setting up to take a derivative. So who's in the role of f of x if I compare these two pieces? What's the function we're taking the derivative of? Sine of x. So another way that we could say this is asking us for the derivative of sine of x.
Oh, wait, wouldn't...
Go ahead.
I don't remember the actual stuff, but I remember going over this for the test because I got it wrong.
What's the derivative of sine of x?
Cosine? Negative cosine?
Wait,
I don't remember.
Cosine of x.
Wow.
That's it.
What?
B is similar. Let's look at C. C looks a little different.
Wow.
Whoops, 16 plus h. So that one, there's a 4 sitting there that looks kind of strange. What do we think f of x is for this one? It might help to look at this guy, at this piece of it. This looks like f of x would be the square root of x, but x equals 16. It's like they've plugged a value in there. Actually, this one you could do an algebra way, but we don't really want to do it the algebra way.
Wait, can you explain that again?
So this is supposed to be f of x plus h. That one's supposed to be f of x. So if f of x plus h is the square root of 16 plus h, then f of x is the square root of x, but x is 16. This one's tricky. I'll grant you that, and D is like it as well.
So is the derivative just x to the 1/2?
Well,
1/2.
Go ahead. Derivative then is
1/2 x to the negative 1/2.
right. But x equals 16, so we need to plug in 16.
Wait, how did you get f of x equals the square root x?
Because I looked at this function. This piece is f of x plus h.
And x is the 16.
Oh.
So it's the square root of x, but x is 16.
Oh. So you kind of just substituted it out, and then when you needed to substitute it back in, you did that.
That's a good way to say it. I put x in so I could take a derivative, but because 16 was there, I put 16 back in. So A and B are similar because they don't have that substitution back in problem. C and D are similar because they do have that issue. So for part D, what is f of x equal to in part D? And x is equal to 5. So take a derivative of 1 over x and then plug in 5. So C and D are tricky, but A and B, they definitely have problems like A and B on AP test where they want you to recognize, wait a minute, that's taking a derivative. C and D are a little harder. It's taking a derivative at a specific point. And again, skip 5B because it's an algebra mess. So I know that this is supposed to be f of x plus h. This is f of x. So maybe this one's easier to look at. F of x is 1 over x, but x is 5. So what this is the derivative of f at 5. So I figured out who f is. I'll take that derivative and then I'll plug 5 back in.
Oh, okay.
Right? I don't want to take a derivative of 1/5. That would just be 0. Take the derivative of 1 over x, then put 5 back in.
So instead of just using f of x, you already have the conjugate of each one?
I haven't done that yet. Like, I wrote the question.
What's that question, Lauren?
So like, you have your f of x plus h, and then right beside it, you have your f of x.
Right?
That's not going to be your f of x. Or like,
Well, this is f of x, but we've already plugged in 5 for x.
look on C.
Oh, this one's a little harder. This is square root of x, but x is 16, and the square root of 16 is 4. So I would have liked it a lot better if instead of writing 4, if they'd have wrote minus square root of 16. I think that would have been a little easier to see.
So just to be safe, always go with the x plus h to figure out everything.
Probably easier, yeah, to look at the f of x plus h. Because the other one's just going to have a number. Now, a and b, it's probably easier to look at f of x because there's no h to mess things up. I think that's the hardest one. After that, especially if we throw out 5b. 4 is just quotient rule, chain rule, chain rule. 5's easy if you throw out b. 6 has a little bit of algebra in it because you got to figure out where it crosses. But other than that, it's not too bad.